So Randall, generative AI sprang into existence, fully formed November 30th of 2022 while we were at reInvent, right? Is it about the
Oh, yeah, absolutely. Or, we're all hanging out at reInvent and all of a sudden this revolution, no. As everyone knows, like this stuff does not happen overnight. The original version of ChatGPT was really just an interface over a model called GPT-3 that had been out since, I don't know, let's say 2019. So, this stuff's been around for a minute, and I think if you really want to go back, you have to go all the way back to Geoffrey Hinton talking about deep learning models and backpropagation and the work that was done in the original ResNet, because the way people were thinking about machine learning before that, it was totally different. They were thinking that they were going to have a much more imperative approach and less of a data-driven approach. Geoffrey Hinton came along and after being told he was wrong by like 200 other professors, was able to prove everyone else wrong. And of course, he won a bunch of awards for that. People forget it was really a lot of his grad students that did a lot of the work. And they came out with ResNet, which was like this machine learning network for identifying images. And essentially, we just move forward from there, from that deep learning into the space of, well, these RNNs, these recursive neural networks, they have the problem of maintaining context. They have the problem of training as they get deeper. So, in breadth of knowledge too. So, you could take traditional convolutional neural networks, you combine them into recursive or recombinant neural networks, RNNs, and you could get some semblance of understanding of language. And then you came up with things like LSTMs, long-term, short-term memory, that had little sliding windows. And again, like you had the problem of context, you had the problem of, what is the real architecture, or am I getting the full context of the question that's being asked? Am I fully understanding this?
So just to put a naive point, or to ask a naive question, what we're talking about there is we're looking almost one token or one word at a time, or very few words at a time, not necessarily understanding the semantic meaning that a native English speaker or a native language speaker for another language might infer on the sentence as a whole, but really just it's not quite letter at a time, but it's really just there's not an understanding of the context that would be evoked in a person's mind.
Right, and the stemming and the vectorization of those tokens, those words, it's still happening in an imperative fashion. It's not happening based on any sort of embedding model or anything like that. So I think a lot of this starts to change when we get to models like word to vec, so that's word to vector. And the cool thing about those is it would start to relate hey, I've got the word king, and that's closely related to man, and then I've got the word queen, that's closely related to the word woman, and it turns out you can just plot all of the semantic concepts that exist in all of these languages in a vector space, and you just create this gigantic vector space, and all of a sudden you have this means of tokenizing your information across this multidimensional space, and it becomes addressable. And once it's addressable, we can start to do some training and we can start to do some back testing. But we still have the problem of, how do I create meaning from more than just one word? Because you can do vector math, you can add the vectors together, but that, if you were to add man and royal, does that give you king? Woman and royal, does that give you queen? But again, that's not a sentence. So we got to this space of okay, what's next? How do we take this to the next level? And that's where there were a couple of models in between. There was at the same time in a different field, not in the natural language processing field, and in a different field for sound and for video and for images, there was this concept of generative adversarial networks, GANs. And these were all the rage, I think it's 2017, 2016 even, where they're going and they're saying, all right, I'm gonna have a generator whose job is to fool the adversary, and I'm gonna train both of them, and they're gonna go against each other. And in that fashion of training the generator, training the adversary to detect fakes, we're actually making a much better kind of network that is able to create this new stuff. And that was fantastic. It brought about a bunch of funny memes and a lot of other cool stuff. And then we take that concept of generation, and we arrive in 2017 in June with this paper called Attention is All You Need, and it introduces the transformer architecture. And the transformer architecture it's taken me a long time to arrive at this. So I'm stealing words, by the way, from other people here. Like, I didn't come up with this concept myself. Transformer architectures are a form of weight expansion, and weight compression, which is not how I had been thinking about it previously. What it does is it asks who, what, when, where questions of the input tokens. So in a transformer, I go in and I say, hey, here's all my embeddings, here are all my tokens. So if I put in the sentence, Mary was 15 years old when she started 10th grade. All of those tokens get put together, and the transformer, in order to expand its knowledge in real time, is taking each of those tokens, Mary, 10 years, and it's asking who, what, when, where relationship questions. It's not really like who, what, when, where, like it's vector math underneath. And it's saying, oh, I'm going to expand this topology.
When I would say that's an interesting point, because you're talking about you're comparing and contrasting imperative models earlier. Like, this is not an imperative model. There's nobody that's told these large language models, these transformer architectures, to ask these questions, but it sort of emerges as you run this learning. I think the other thing you mentioned too with GANs is that's essentially a form of supervised learning, because you have two models that are sort of trained, like they're working against one another, whereas with the transformer architecture, it's strictly an unsupervised learning mode, at least in training the base model, and not necessarily later in how we use it. So it's kind of interesting changes in thought processes that were evolving around that time.
And it's interesting too, because it took a hot minute for transformers to catch on. Because
I don't know about that. I think you have a video that would tell a different story of you in September of 2017. Is that not right?
So in September of 2017, I was definitely on a Twitch stream talking about transformer models, and
you knew where this all was going at the time, right?
Yeah, totally. I could predict the next 5 years. Absolutely, I knew exactly what was going to happen. I
don't know. You were talking about low rank adaptation. There were talking a lot of the concepts that are popular today were in academia in 2017, and obviously you were well read into that space. So to go back to where we started this conversation, did this emerge fully formed in November of 2022? Of course not. Yeah. This is a conversation that was happening in academia it goes a lot further back than 2017, but in terms of large language models, the transformer architecture really sort of advanced the state of the art, but it took a little while for that to filter into the public consciousness to become available.
And the transformer architecture is the basis for a lot of things, but I think what we failed to realize early on is that these generative pre-trained transformers, like just feeding everything forward and then back propagating, we didn't think that was like a viable approach, because transformers, these models, they actually converge. The learning rate is lower at first. So if you look at the learning rate of a traditional convolutional neural network or RNN, it actually has a pretty nice curve, like it continues increasing. Whereas the transformer models, you got to train for kind of a hot minute before you see any movement.
Well, yeah, and if you draw a line between those initial data points, you get the wrong answer, because you've got a static slope, and you're like, okay, it's another linear model. Whereas what we've seen, as you had to get to billions of parameters, is like, wait a minute, this is closer to an exponential curve.
And there are diminishing returns with larger and larger models, actually. That's why GPT-4, they actually did a mixture of experts model as opposed to just growing the model to more and more parameters.
So all other things being equal, bigger is not necessarily better.
Correct. Sometimes it's the tokens you put in as well as the interface. That was the other thing. I think that someone should publish a paper that's called "All You Need Is the Interface." We have attention is all you need. Interface is all you need. That was the thing that really happened that brought about this generative AI revolution that we're seeing right now, is that the transformer architecture eventually became the generative pre-trained architecture, the GPT, the GPT-2, GPT-3 side of things. And then we got to ChatGPT when the interface around it came out. And that is what brings us to where we are today, where we are just going 100 miles an hour in this space, and we have a much better understanding than we had previously.
Well, it feels like the state of the art is in some ways following the what we've seen, what you explained with transformers, right? Is that there's almost an exponential curve in terms of adoption, in terms of the excitement about the abilities of these models. Obviously, they needed to cross a certain threshold of capability so that they had, that we could build upon them. But it's interesting to see that that curve is continuing as it releases into the public consciousness, business use cases, people's home needs and
The time from academia to production has never been faster, and the lines between academia and the hyperscalers has never, they don't exist anymore. They're one and the same. A paper gets published on Friday, we see it in production on Monday. It's just a lot of fun. This is, one of those times in our industry where we get to be part of big changes, and I'm really excited about it.
I love it. It's super exciting for the impatient too. It's like, I hate waiting for something, right? And there's a paper out. Like, okay, I don't have to. I can use my watch instead of a calendar or something to predict when that might be accessible to the general public. That's a fantastic background on the history of generative AI, on the transformer architecture that underpins it. Randall, thank you.
Thanks for chatting with me today.